Okay, guys. Well, periods 1 and 3. Hi. Let's see. I think that might be a clearer picture. So 12.1, even though we've been on chapter 12 for a couple days, we're officially in chapter 12, tangent lines. Okay, so a tangent line is a line that intersects, meaning it touches a circle at exactly one point. It's really important. It only touches it at one point. That point right there is called the point of tangency. They got real creative when naming it. A line is tangent to a circle only if it is perpendicular. Meaning forms a 90-degree angles to the radius, a radius drawn to the point of tangency. So meaning that here's my radius, it comes up here and touches this point of tangency, and right there's a 90-degree angle being formed. Which, what do you think is created right there? Oh, that's a right triangle. Yay, right triangles. We love right triangles. Okay, so they can even be made from circles. We want to determine if AB is tangent to circle P. So if this is a right triangle right here, meaning if that's a right angle formed with this line that is tangent to the circle, and it forms a triangle, what formula do you think we would use to prove that this is 90 degrees, making it a right triangle? If you said or thought Pythagorean Theorem, you are correct. Show them what they've won, Mrs. Black. Your very own Pythagorean Theorem question. So remember that your legs are always the A and B, and your hypotenuse, which is across from your 90-degree angle, is always your C. So we have 8 squared plus 15 squared equals your hypotenuse, 17 squared. And our hope is that they hold true and equal each other once we do the Pythagorean theorem. So 8 squared is 64, 15 squared is 225, and 17 squared is 289. Well, when I add 64 and 225, I get 289. And are 289 and 289 congruent? Equal? Yes, they are. That means that this is a right triangle. Woohoo! And because it's a right triangle, then that line is tangent because it is perpendicular, forming a 90-degree angle to the circle. Next up, this triangle here. We want to see, hey, is that a 90-degree angle? AKA, is this line tangent to the circle? Well, let's give it a shot. So 14 squared plus 11 squared equals, what does it equal? Oh, well, this piece is 5. We don't know this piece. Oh, this piece is 11 because it's a radii. So this entire piece here is 16. And we want to square 16, don't we? So we're going to do 14 squared, which is 196. Why am I forgetting how to write for a second? And 16 squared is 256. Well, when I add these together, I get 317. And 317 is not equal to 256. So that line is not tangent, and it is not a right triangle. No way, Jose. Okay. This time, we know that it is tangent to circle L. It is. Okay. We want to figure out a side. So again, we're going to be using Pythagorean Theorem. This is where my right angle is, right? Where the radii and the line of tangency intersect. So these are my legs. 7 squared plus 19 squared equals x squared. Okay, well, this would be 49 plus 361 equals x squared. Well, 49 and 361 are 410. And then, of course, I take my square root and my square root. And x is equal to 20.2. Bada bing, bada boom. Okay, so let's look at this one. Well, this is where my 90-degree angle would be. I have 11 squared plus x squared plus, oh shoot, I only have this part. But fear not, I know that this segment and this segment, because they're both radii, are the same measure. So when I add them together, I get 18. 18 squared is what I want to do. So 11 squared is 121 plus x squared equals 324. All right, I end up with x squared equals 203 and x equals 14.2. Okay, knowing that information, I want you guys to do number 6. So don't forget, you need this whole measure right here. All right, so number 6, that's all you guys. All right, flip your paper over, and we're going to assume that the lines that appear tangent are tangent. And then we're going to find the value of x. So I know this is 90 degrees. I know that this is 90 degrees because they appear tangent, right? Well, it wants me to figure out this degree measure. Oh, shoot. How do I do that? Well, I could divide it up and get creative, or I could count the number of sides. 1, 2, 3, 4. And do you remember if we do the number of sides, 4 minus 2, and multiply it by 180, we end up with the total measure of angles, which should be 360. It's a quadrilateral. And a quadrilateral equals 360 degrees. So 360 minus 90 minus this other 90 minus x, not minus x, minus 117 will give us x, which we know once we subtract all of those is 63. All right, this one, not quite as tricky. We know this is 90. We know this is 38. It's a triangle. How many degrees does a triangle equal? Well, why don't you guys solve for number 9? Okay, more tangent line properties. So 2 segments from the same external point are tangent to a circle, then they are congruent. That means since these points are both originating at B and they are both tangent to the same circle, then they're equal to each other. The same goes if a polygon is circumscribed around a circle. So right here, in this case, we have a triangle. We would know that DB and EB are congruent to each other. We would know that EC and FC are congruent to each other, and we would know that AF and AD are congruent to each other. Okay, so taking that information, here they are originating from the same point outside the circle, and they're tangent to the same circle. That means they're going to be equal to each other. This one says solve for x. So we're going to do 5x plus 23 equals 8x minus 19. All right, I am going to I'm going to have 3x plus 23 equals negative 19. And then 3x equals, negative 3x equals negative 42. Oh my goodness. So negative 3x equals negative 42. I'll divide and get x equals 14. Negative 42 divided by negative 3 gives me a positive 14. Okay, so this one wanted us to solve for x. This one wants to solve it for PQ. Okay, so PQ is right here. But the first thing we have to do is figure out what in the world x is. So 14x minus 13 equals 8x plus 5. All right, I'm going to have 6x minus 13 equals 5, and then 6x equals 18, and x equals 3. Well, now for PQ, I'm going to just plug that 3 in. So 14 times 3 minus 13, and I'm going to get 29. I know that PQ will be equal to 29. Okay, so this one right here is the hardest one that I want you guys to try today. You're going to need to figure out why eventually, okay, which is SV. But first, solve for X. Second, solve for ST. And then solve for SV. All right. And give me your answer right here. Let's see what you get. Okay. Well, remember, if they come from the same point of tangency, they're congruent to each other. So if this is 23, then this piece would be 23. And if this piece is 27, then this piece would be 27.1. Sorry. Okay, well, we've got something tricky we need to figure out. We need to figure out this part, this part, this part, and that part. So what we're going to do to figure out this is we're going to do 37.5, and we're going to subtract that 23. We're going to get 14.5. So I know that is 14.5. And I therefore know that that piece is also 14.5. Next up, I want to figure out this piece. So I'm going to do 52.5 minus 27.1. I am going to get 25.4, which I know is also this piece is 25.4. I'm going to go ahead and add up all of my sides now. So I'll start with the two long ones that were given to me. 37.5 plus 52.5, so these two. And now 14.5 plus 27.1 plus this 25.4 plus 23, because I'm also finding the perimeter. When I add those together, bada bing, bada boom, shabam, I get 180. You guys need to do 13. And I will see you next class. Bye.